Hi everyone, welcome to the first video lesson for Math 118, continuation and alternate format. It's on probability. It's an introduction to our last unit on probability calculation. So what we're going to learn today are a lot of fundamental parts of probability. So the first thing we're going to talk about is proper notation. So it's going to be of the form P is equal to something in brackets. It might be x is equal to 2, and then we'll put the probability after that. The probability is always going to be a number between 0 and 1, and we'll round to 4 decimal places for consistency with what we're going to do later on. We're going to be talking about tree diagrams. We're going to be talking about finding probability of events given information, complementary events, and then ways we might see information organized for and getting them from in new ways, contingency tables and Venn diagrams, which again are common ways of seeing information presented. So the reason why we're doing this is it's leading into the next part of our course. So we just finished a unit on descriptive statistics, which are ways of describing things that have already happened. And the next thing we're going to be doing is talking about inferential statistics, trying to draw predictions, make comments on how likely something is to happen in the future. So that's what probability is all about. So the first thing that we need to realize is probability and percent go hand in hand. So the fact that something has a 50% chance of happening, that means the probability that the event happens is 0.5000, right? So just like we talked about in Math 117, converting from decimal to percent by dividing by 100 and removing the percent sign. That's what our probabilities are. We can think about them as a percent chance of something that's happening. So events can have a 0% chance, which is that they're impossible to happen, or they can have a 100% chance, which means they have a probability of 1 of happening. And so if you need to, you should have access, if you search in D2L, to go back and find your Math 117 notes on converting between percent from decimal. It might be useful. If you're having difficulty finding those notes, just let me know and I can help you get access. Okay. So the next thing we need to go over before we start doing any calculations is some of the terminology involved in probability. So we just talked about, so probability is a number representing the likelihood that an event will happen. Our probability, when we're asked for probability, always will be a number between 0 and 1, and it's different than the percent chance, which is a value between 0% to 100%, okay? And so when you're asked to calculate the probability that happens, give your answer in the decimal form between 0 and 1, not as a percent chance. Okay, so as you're going through these videos as well, know that you can pause at any time. There will be times when I want you to do a practice activity and you'll pause and then the results will show up on the screen. And so this is the first example of something like that. So you've got 6 different probabilities listed and 4 different events. And we want to match each of the list items to one of the probabilities. So 2 probability values won't have an event matched to them. Pause the video, try and figure that out. What is the probability that an event is impossible? What for an event is certain, unlikely, and occur more often than not? Okay, and then you can resume your video and check your answers. There you have it. So if an event is impossible, it has a probability of 0. If it's certain, it has a probability of 1. If an event is very unlikely to happen, but will happen every once in a while, we could use the probability of 0.01. That means that there's 1 chance in 100 trials that we expect that to happen. And then this event will occur more often than not, a probability of 0.6, but a 60% chance, so 6 times out of 10, more often than not. Whereas 0.99 would be highly likely to occur. So when we talk about calculating probabilities, we can talk about probabilities for experiments, procedures, or events, right? So those are the things we're trying to figure out, or trials that we're trying to figure out the probabilities related to. The outcomes can be qualitative. So the chances that a red ball is drawn, that you flip a heads, that the question has a true answer or a false answer, or they can be quantitative in nature. And we'll be building into more of those sorts of values. So what's the probability that somebody has a height greater than 180 centimeters? What's the probability that a baby weighs more than 2,000 grams? Okay. And then we can to look at the outcomes of particular experiments. We introduce a new term here. We say an outcome is a subset of the sample space. A sample space is a list of all possible outcomes for an experiment. And so we're going to see, because it's a list, we're going to see set notation come up again. We introduced set notation when we were talking about mode as a way of describing central tendency, when we could have a list of different most common values. So for a true or false question, if we want to talk about what the sample space, what all the different possible outcomes for that is, this that outcomes are true or false. We could write that the set is equal to true or false, or if we want to simplify it, if we just write T or F, and our point will get across, we can reduce the sample space that way. Okay. For two true or false questions, the sample space would be all of the different outcomes. So we could have two trues, we could have a true and then a false, we could have a false question and then a true question, or we could have two false questions. When we think about experiments, they tend to be ordered in nature, and so having a true question followed by a false question is different than a false question followed by a true question, which is why we see those two different options listed in the sample space. And so once we know what the sample space is interested in or consists of for a particular experiment, we could talk about the probability that we have an outcome of true, right? The probability that one of our potential outcomes happens, or we could have the probability that we have an outcome of two true questions, right? And so we'll see that notation come up. So next activity for you to do is to try and think about what the different list of all the outcomes are for the following experiments. So pause the video and try and think what the sample spaces look like for these different experiments. Okay, so for rolling a dice, we've got 6 different possible outcomes. You could roll a 1, a 2, a 3, a 4, a 5, or a 6 for tossing a coin. You could either get a heads or tail. Tossing 2 coins, you could get 2 heads, a head then a tail then a head, or then 2 tails. And for blood types, including the Rh factor, we can have O positive, O negative, B positive, B negative, AB positive, AB negative, O negative, or O positive. Okay. The final bit of this first video is we're going to talk about a nice device for organizing and thinking about different outcomes, especially if we have repeated trials. So maybe it's hard to think about what it looks like for flipping a coin twice, and so we're trying to figure out what that would look like if we flipped a coin twice. And so one of the ways we can organize ourselves is to make what we call a tree diagram. This will also come up again in the next set of notes when we talk about calculating probabilities for repeated trials. A tree diagram is a good way of tracking those. So the way a tree diagram works is we start with a starting point and we think about the different outcomes that can emanate from that first branch. So what are the different things that could happen? So maybe it's that we get a head followed by a tail, or we could get a tail after the first flip, and then after another flip we could get another head or then a tail, and then we could get a head or a tail. If I read down through the chart, then I get my sample space is head, 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 tail, tail, head, or tail, tail is the fourth branch that we could travel down. Okay. Or, as given here, we can also use tree diagrams when we want to think about multiple events that could have different outcomes. So you could have a disease and test positive. That would be what we would expect to happen from a medical test. You could have a disease and you could test negative. So that would be false negative, right? You could have no disease and test positive. That's what they refer to as a false positive. Or you could have no disease and test negative, right? Which again would be how we'd expect a treatment to work. So last activity for this particular video, and then I'll start a next video, is pause the video and draw a tree diagram to determine the sample space for the result of flipping a coin, and I missed this 3 times. So we've talked about flipping a coin once, flipping a coin twice. What are all the different possible outcomes of flipping a coin 3 times? Use H for heads and T for tails. Okay, so it turns out that for flipping a coin 3 times, there's 8 possible different outcomes. Each time we could get a head or a tail, and so we can either get 3 heads, we could get 2 heads followed by a tail, a head, a tail, and then a head, and so on. Going through and creating the tree diagrams gives us a way to ensure we don't miss any of the possible outcomes. Okay, come to WebEx if you have any questions. Otherwise, continue on the next video and continue completing your notes so that you can do the worksheet and be prepared for the test.